So, introduction to this number here. How do you say this number? How do you say that?
Eulers.
That's how I would have said it too, but he's not. He doesn't have the same.
Eulers. You said it.
Very good.
You said it.
I've said it before. Okay. Yeah, it's pronounced Eulers. I don't care how you pronounce it, but that's that. So I'm going to teach you guys about a new number called Euler's number. It has something to do with exponential functions and a special type of exponential growth called continuous exponential growth. So we're going to look at that. And then basically we're going to do graphing with that, and that's it. We'll be done. So that being said, let's roll forward here. So what is Euler's number? I feel like something's wrong here. Hold on a minute. Something's not right. Oh, I know why. I know why. I'm on the wrong slide. Sorry, just a moment. It is, but that was the student notes. I had some extra stuff on mine that I wanted to go over with you guys. Okay, back to where we were now. Okay, so guys, let's take a look at this. Quiet down, please. So, suppose you want to invest $1. Okay, now, I pick stupid numbers because it makes the problem work out the way we need it to, but just follow along with me. Suppose you want to invest $1, and every bank promises to give you a 100% APR. Now, Bank 1 is going to compound your interest annually. So, here we go. Let's do that. So, if you want to compound it annually, you guys remember this little formula here? Right? That was last time. So, what's my starting amount? $1. What's my interest rate? 100%. If you divide that by 100 to make it a decimal, what is it? No. No.
One.
It's 1. And we're compounding this how often? Which means that n equals 1. Yeah, 12 would be monthly. And then we have 1 here. And all the problems we'll be looking at is just for 1 year. Now, let's take a look at this. This is 1 plus 1, which is 2. 2 to the first power is 2, so the answer is 2. So basically, and if you think about it, it makes sense anyway. They're telling you they're going to give you 100% of what you invested by the end of the year. So you have $1, they give you 100% of that, you got $2. Makes total sense, right? All right. So, 1 year. All right, now let's take a look at another one. Bank 2 wants to compound it, and you're not writing this, just watch. Bank 2 wants to compound this semi-annually. So what goes on top here?
2.
1 still goes there. We're still doing 100%. What goes on the bottom? 2. And we're still doing just 1 year, so times 1. Now for this one, I think I went ahead and just calculated for you. It's 2.25. So now you got 25 more cents. We saw last time that the more often they compound it, the more money you get out of it. Now let's take a look at another one here. How about quarterly? So what goes on top? Bottom? And once again, I calculated for you, and we get a little bit more money. Instead of 25 cents, now we get 44. So if they compound it quarterly, you get a little bit more. Not very much more, but a little bit more. All right, let's do monthly. What goes on top? Bottom? You want to take a guess? So $2.60 of some kind? Look at you. Look at you. All right. All right, now we're going to start getting weird. We're going to compound it daily. That means it's 365 times a year. 2.714. You get 10 cents. That's not much more, right? How about that? Does anybody know what that is? That's per minute. That's how many minutes are in a year. 525,600 minutes, right? So, there you go. Right? Huh? Okay. These girls have been back much. All right. Girls, go quick because Samantha needs to use the restroom, okay? All right. Here we go. So, bank 1 gives you 2. Bank 2 gives you 225. Bank 3 gives you 244. Bank 4 gives you 261. It's going up every time, but you'll notice it's going up less and less every time. You notice that? Like the first time it goes up a whole quarter. The next time only like 20 cents. Maybe 20 cents again there, but there's only 10 cents. And here, it's not even a cent. Okay? So what's happening is it's approaching a limit. It's not going to go up higher and higher forever. It's getting closer and closer to a number, an asymptote. Okay? It's approaching an asymptote. So, as n approaches infinity, the outcome approaches this weird number here. So as n gets bigger and bigger, you get that number, and it goes on forever. There's no pattern to it. We call it an irrational number, but it's actually a very special number. It's called Euler's number, and they represent it with a letter E. So usually in math, letters represent variables, right? Something we don't know the value of, but in this case, this is actually like pi. Pi is a number. We just use a symbol to represent it, right? So this is a little bit like pi. It's a special number. The example I give you shows you one way that E just kind of pops out in mathematics, but it does it in other places too. It's actually a really neat number. So let's go ahead and talk about that a little bit then. So what is Euler's number? It's that approximately, 2.71. On your test tomorrow, I'm going to ask you what's Euler's number. You could stop at the 1, 2.71. Yeah. Is the result of letting n go to infinity with that formula there that I just showed you in the last page. Another way you could think of it is taking your compound interest formula. If you let n go to infinity, this piece right in here we saw, this piece equals E, right? And that's this piece right here. That piece just becomes E. And so your formula changes into this, and we're going to be working with this today. Okay? So, that is what we call the continuous growth formula. It's what happens when you break up your interest rate into infinitely many pieces and compound it infinitely many times. Okay? And what it does is it gives you the highest possible answer you could possibly get. Every time you take up your interest rate, you get a little more, right? But E is the one that gives you the highest. Okay? So, y equals PERT gives you the best possible output. It's called the continuous growth formula. Why do mathematicians care about this? E is kind of like pi. It's not a number that you could say people invented. It's more like a number people discovered. Okay? It's just there. Pi is just there. Pi is basically the ratio of a circle's circumference to its diameter. That's where that number comes out. E just comes out of exponential functions naturally, and I showed you one way it just comes out by itself there. If you let n approach infinity, it just pops up. There it is. There's a few cool numbers like that in mathematics. And I put over the word nature. It's just one of those natural numbers, and because it's so natural to exponential growth, it actually works much better in calculus. So in calculus, when you're working with exponential functions, you want to work with E. In fact, if you're working with something that's not E, you want to change it so that it is E, so that it works out nice and clean. E is just a really cool number. So for you guys, it's more of a like, hey, here it is, this is how you work with it, but you don't really get to appreciate the beauty of it really until you get to like calculus. So anyway, there's our continuous growth formula. Let's go ahead and label some of this stuff. What do you guys think P represents? Yep, starting amount. So let's label that. What do you guys think the R represents? It's the growth rate. Good. And once again, you're going to get that by doing your percentage divided by 100, right? What do you guys think's up with the plus and minus there? There you go. If it's an increasing function, it's plus. If it's a decreasing function, it's a minus. Okay? And t is usually just going to be time or your input, but a lot of times it's just time. Yep. E is Euler's number. And it's approximately 2.71. Okay? Just so you guys know, before we start doing this problem, I want to remind you of something. We've learned 3 formulas when we're working with these word problems. Okay, we started off with this one, right? That should look a little familiar. And then we did compound interest, and we got this guy. And now we're learning a third one. And so what's going to be kind of important for your test here is you have to know when to use each one. How will you know when to use each one? Now, I think I put it on the very last slide of today's notes. So I think I'll go ahead and just jump to the end, actually. I didn't need to write all those out. There it is. So when you're reading these word problems, what you want to do is you want to look for some key words, okay? If you guys see the word compounded, it's probably the middle one. That's the formula you're going to use. If you guys see the word continuous, it's the one we're working with today. If you don't see the word compounded or continuous, it's probably the one we learned back in 8.2. Okay? So we've learned 3 different ones when working with word problems, all right? So that being said, let's go ahead and get started here. So suppose you invest $1,500 into an account with an APR of 10% compounded continuously. How much would there be after 1.5 years? So there's a key word up here. Continuously. When you have that word, that tells you we're using this. Well, we're just going to actually let the calculator. There's an E button on your calculator, actually. So the calculator do it. All right. So here we go. What is the starting amount? Is this adding, or am I increasing or decreasing the amount of money? We're increasing. It's when you're compounding interest, you're increasing. So it's going to be a positive. Now you don't need to write the positive, but I'm going to. And what's my R value? 0.10, right? And how many years? T. 1.5 years. So there you go. So it's just like all the ones. Once you know what formula, you just plug stuff in and go for it. So let's go ahead and have you guys come grab a calculator if you don't already have one. I'll show you how to punch this into the calculator. Here. I think I did something wrong. What you guys are going to do is you're going to push 1,500. 1,500. And then we got to find the E button.
I didn't put the E button.
That's right. So you're going to push the button that says second on it, located in the top left, and you're going to find the button that says LN. Your guys is a little bit higher up than mine. So you're going to push second and then LN, and you should see E with a little caret on it with some parentheses. Second.
Do we like hold it or no?
No, you just click it. Huh? All right. So now we do, in the parentheses, we're going to type 0.10 times 1.5. So 0.10 times 1.5, close parentheses. Oop, I lost my thingy. I'll see if I can bring it back. But that's it. After you do that, you've got your answer. So go ahead and push enter. You guys should be getting 1742.
Yeah, but what do we? Yeah, what is it? What is it?
Double check how you punched it in your calculator.
She didn't listen.
Harsh. Well, let me do it. Okay. All right, let's continue. You can start now, Annie, and then you can finish tonight for homework, okay? All right, here we go. This is guided practice. So, let's read it really quick. Caffeine leaves the body at a continuous rate of 17% per hour. How much caffeine is left in the body 8 hours after drinking a cup of coffee containing 100 milligrams of caffeine? Adrian, what formula are we going to use? Huh? Okay, so we're going to use this. Adrian Canizales. Well, I was. Now I'm talking to Adrian Canizales. Adrian Canizales. How did he know to use that formula?
It says,
Henry? Which one? Pay attention.
Oh, it says that they're continuous rate.
There you go. When you guys see that word, that's how you know to use that. Okay? Next question is, Paris, what am I going to put here for the P? No, that's going to be my R. Now, the P represents the starting amount of coffee, which is 100. So I'm going to put E there. Next question is going to go to Jonathan. Somebody's headphones are pretty loud. If you guys could turn those down, please. Jonathan's not with us. Leslie, are we increasing or decreasing? No, we're actually decreasing because it says that your body is like using up the caffeine. So since it's decreasing, we're going to put what? Negative. All right, next. I'm just plugging in the numbers that it gives me right now. Michael, what am I going to plug in for R? Uh-huh. Kind of. 0.17, right? Because you want to divide it by 100. And we're going to multiply that by something as well. Kiara is not with us today. Hannah, what am I going to multiply by? The time is 8. Okay, and then you guys get to punch it in on your calculator. So go ahead and punch that in on your calculator, see what you guys get, and I'll call on you to share it out in just a second. Get Miss LaFontaine. Huh? Yep, 25.67, and we could say milligrams. So basically, after 8 hours, we started with 100. We would only have 25 milligrams left. Okay, so there's that. So throw some student practice at you guys here for a second. Wherever. I'm not. Did I print it for you or no? Okay, so just go ahead and do what you can. You don't have to. Please don't take the time to copy down the problems. Just do them on the back of your. So I think what I like about the you did. I think what I like about the continuous growth is because that's how things generally kind of grow in nature. You know, it's kind of like when we did our Alice in Wonderland thing. You guys remember that? Yeah. Her growth was sporadic. She was one height. She ate something. Boom. She was another. She ate something. Boom. She was another. Right. But in real life, things like mold on a piece of toast, it's not like this and all of a sudden it's like boom, it doesn't do that, right? It grows continuously, right? And so exponential growth kind of with E better models reality because it models something that's continuously growing. Honestly, they'll both give you a right answer. It's just that since this one models it better, you get cleaner answers, like I said, in calculus and stuff. So, anyway, so that's our three formulas. Today we worked with the one on the far right. Yesterday we worked, or not yesterday, but Friday, we worked with that one there. And we worked with that one a little while ago. On your study guide, you're going to see all three types of word problems. Remember, you're looking for key words. You see the word compounded without the word continuous on there, just compounded like annually or something. That would be this guy. If it says continuous, it might say compounded. But if it says continuous, it's that guy. If it doesn't say one of those keywords, you're using this one from 8.2. Okay? We're also going to talk about graphing. The good news is the graphing process is identical to the one we learned last time. You guys remember how to graph exponential functions. What we did was you started by finding your horizontal asymptote. It's this number here, y equals c. We also found our y-intercept. It was taking the first number and adding it to the last number, right? And that was your y-intercept. And then we used a little chart here to figure out what the shape would be. And it's actually the same chart. It just looks a little bit different. Up here, we realized before it had to be, well, if this number is bigger than 1, then it looks like this. Now, let me ask you guys, E, is that bigger than 1? Yeah, it's 2.71, so it looks like that. Now, if they write it like this, 1 over 2.71, that's less than 1. That's the one that looks like this. Okay? And then once again, if your number in the front is negative, it flips it upside down. So you guys should probably add these to your notes here. And I'll wait for you for a second. We'll graph a couple and we'll call it a day. So, here we go. Example 2. I don't think I printed this, right? All right, go ahead and write it down. Our goal is to graph this. My horizontal asymptote is 4, right? So let's graph that. 1, 2, 3, 4, dotted line. How do we know it's 4? It comes from that number right there. No, Hannah. No, Hannah. Okay, next, what do we want? Y-intercept. The y-intercept is 0, comma, what? 1. Why is it 1? Because you do -3 plus 4. Okay? So we're going to put a dot at 0, 1. The last thing we got to do is we got to do our shape. Now when it's 1 over e, that means it's less than 1, right? So we're going to look at our chart that we drew earlier, and I'll give you guys 3 options. Look at your chart. I'm not going to put the numbers on here. I'm just going to draw the shapes. Which one is it? A, B, C, or D? D? I agree. So it's going to go like this. It goes like that because we have 1 over e. So we're in the right column of the chart you guys copied. And we're in the bottom row because the p-value is negative. We good?
No.
Can I erase? You got a cell on to pick on? All right, write down this one.
He was Francis.